Hello, everybody. Welcome to UACNJ. And here we are at the Jenny Jump State Forest, the United Astronomy Club of New Jersey Observatory. And oh, my script went away, so hold on one second. There it is. We're also live streaming on YouTube and various other social media, so you can catch us there if you don't make it out here on any week. While people are continuing to pull in, and as we get ready here, just a couple of business items first. We are a nonprofit volunteer organization, so we do rely on donations, etc., from the public. So if you do notice our jar here or our store inside, if you can support us, and I need to go back and be in the shot of the camera. Sorry about that. Sorry, everyone. And then also for our live audience here, also the observatories, of course, are in that direction. And the comfort station here is to my right, your left, if you need to make use of that. Also, just a safety reminder, lights. Though we don't want, when it gets dark, we don't want to necessarily ruin our night vision, so judicious use of flashlights is appreciated. We do want you to keep safety in mind, so when you are leaving, please do use your headlights, and please, if you do feel it necessary, do use your flashlights to get around. So thank you for that consideration. Yes, there we go. And we'll be having a Q&A session after the presentation. If you are here, please wait for this microphone to come to you in order to ask the question. The people online, of course, can type their questions in online. And with that, let me get into introducing our speaker, Bill Murray, today. And I have to switch, so hold on. There he is. Bill is an amateur astronomer for more than 50 years. Bill was employed as a software engineer in the electron optics division of the David Sarnoff Research Center in Princeton for 18 years. More recently, he has taught high school mathematics and physics at Trenton Catholic Academy in Hamilton, New Jersey, and is currently employed as planetarium technician at the New Jersey State Museum Planetarium in Trenton, New Jersey. He has been a longtime member of AAAP, an amateur astronomy club out of Princeton for 36 years. And Bill has held the various posts there as observatory chairman, secretary, program chairman, assistant director, and director in that club. Without further ado, by the way, my name is Paul, before I forget to tell you if you want to talk to me, but without further ado, let's hear from Bill.
Thank you, Paul. So my talk tonight is on the life and legacy of Charles Messier. Who is Charles Messier? He was a French astronomer, lived back in the 18th century. He was a contemporary of George Washington and Benjamin Franklin. And the question really is, why do we care about the work that was done by a French astronomer 200 years ago? So if you're here tonight, you're probably interested in looking through telescopes at the stars and looking up. It's definitely a possibility, knock on wood, that we're going to actually see something tonight. And so the question is, when you have a telescope, either something that has been gifted to you or something you've bought for yourself, or you come here to a public observatory, what is it that we look at? Well, normally we start off by looking at things like the moon and the planets. Unfortunately, in the evening skies right now, there aren't any planets to look at, but the moon is up tonight, so we'll probably look at that. And then After you get tired with your telescope of looking at the moon and the planets, what else is there to see in the night sky? Well, there are some double stars and some stars that have different colors, and you can look those up. That's a fascinating thing to look at. But a lot of people move on to something called deep sky astronomy, and that's where Messier comes in. And he has a lot to do with some of the objects we're going to be looking at tonight, hopefully. So, who was Messier? He was born in June of 1730 in the town of Badonviller, France, and he was tutored at home by his older brother in mathematics and the sciences. And his interest was sparked in astronomy by viewing the Great Comet of 1744. And when I say Great Comet, I mean a great comet. Okay? We don't seem to get these much anymore these days. But the comet of 1744, also known as Comet de Chasseau, after the French astronomer who discovered it, was at its brightest. The nucleus of the comet was brighter than the planet Venus, which is magnitude -2 and easily visible in the sky. And at its closest approach to the sun in March of 1744, it was actually visible in the daytime. So, and this is a drawing of the comet. It had 6 tails before dawn in March of 1744. And I can imagine that seeing something like this in the night sky would spark anybody's interest in astronomy. So Messier's brother took note of his interest, and when he was 21, he got a position for him as apprentice to the French astronomer Joseph Nicolas de Leslie. And de Leslie was the chief astronomer of the French Navy. All navies at that time employed astronomers because they needed to have the clocks on their ships adjusted to the correct time. They needed to find latitude and longitude and create tables for the French Navy to use. And that was de Leslie's job. And he built an observatory for himself in central Paris at the Hotel de Cluny, which is still in existence. It's an art museum today. Looks actually pretty much similar to this drawing drawn back at the beginning of the 18th century. And Messier did his observations from the roof of the Hotel de Cluny. Okay, so comets. We know them today as icy bodies that orbit the sun, but comets exerted a particular fascination and almost a morbid fascination for people back in the 18th century, both in public imaginations and the imaginations of scientists. This is an example of that. So this is a political cartoon from the late 18th century, and it shows a representation of John Bull, who is a character who represented Great Britain, similar to the way Uncle Sam represents the United States today. And he's looking through a telescope similar to the size of the telescopes that Messier used at a comet. And he's saying, "Aye, Master Comet, you may attempt your perambulations or your devolutions for what I care, but make sure the word of an old man, you'll never reach the sun, depend upon it." The sun being King George III, and the comet is Napoleon. And he's being prevented by reaching the sun by the ships of the Royal Navy. So comets did have a big hold on the imagination of people in the 18th century. And the question is, why? Okay, why was the search for comets such a big deal in the 18th century? And the answer is, when astronomers looked at the night sky, they didn't really understand what they were seeing. There was very little that they knew about astronomy. Telescopes were brand new. They were less than 100 years old. They were seeing things that they didn't understand. But one of the few things that they did understand was comets. They knew what they were, and they could calculate their orbits. And the reason why they could do that is because of this gentleman here, the English polymath scientist Isaac Newton. His dates are there, 1642 to 1727. He was born in the year that the Italian scientist Galileo died. And he was recognized very early as a prodigy and a genius, but he was always a loner in his life. Never had very many friends and preferred his own company to the company of virtually anybody else. He went at a very young age to Cambridge University and was just completing his studies there when in the year 1665 plague hit England. and the schools closed down, the businesses closed down, the university closed down. I used to think that this was, something that's historical in the past that we would never repeat, but we've just come out of 2 years of pretty much exactly the same thing that Newton went through. So when the university closed down, Newton returned home to his home in Woolsthorpe, which is out in the English countryside, with really no one to talk to and nothing much to do except what was in his own imagination. And what he ended up doing in those 2 years by himself without any help completely changed the world. In those 2 years, he invented calculus. He completely redid the science of optics. He completed the design for a new type of telescope we call after him a Newtonian telescope. He completely redid and categorized all the laws of modern physics, and he discovered the law of universal gravitation. And after completely revolutionizing science, far beyond what any scientist in Europe had done in those days, after the plague abated, he returned to university in Cambridge and told exactly no one what he had done. A few years later, okay, one of the few people who Newton did get along with was the astronomer Edmund Halley. Okay, Halley was Newton's pretty much his opposite. He was a gregarious. He was well liked by everybody. He was rich, which helps a lot, and he was part of a discussion that was going on in English universities in the 1680s, and that discussion involved comets. Okay, in the year 1682, a bright comet had appeared in the skies over England that Halley had observed. And this sparked a discussion among scientists in England about what the path of comets around the sun was. Scientists were pretty sure that they were bodies that were in our solar system, and they were trying to calculate their orbits. And nobody had the mathematics to do that at that time. And one day somebody said to Halley, who was one of the few people that Newton liked, well, Newton might have something to talk about this or say something about it. Why don't you go talk to Newton and see what he has to say? And so Halley went to Newton and he said, we're thinking about this problem. We're trying to figure out what the path of a comet around the sun would be. And Newton immediately answered, it's an ellipse. And Halley said, well, how do you know that? He said, well, I figured it out a long time ago. And Halley said, well, can you redo the calculation for us so we can see how it's done? And Newton said, sure, I'll do it. And after prodding a little bit by Halley, he came up with a paper describing his method. And when Halley read it, he immediately realized what Newton had done in those 2 years when he was by himself at his home. And he said, you have to publish this. This is revolutionary. No one else in the world has done anything like this. And so after a bunch of prodding by Halley, okay, in the year 1687, Newton published the work Principia Mathematica, which is still regarded as one of the best and greatest scientific works ever created by the mind of man. Completely revolutionized the science of physics, describing the laws of physics, gravity, and the motions of objects through space. Okay, but Halley did even more than that. He actually had to pay for the publication of the Principia because normally books like this would have been published by the Royal Society. Both Halley and Newton were members of the Royal Society, but the Royal Society was broke. So it's thankful that Halley was able to pay for the publication. The reason the society was broke was it spent all of its money the previous year publishing a book called The History of Fish. And they had thousands of copies, which for some reason was not a bestseller. And Halley ended up taking payment from the society for the money he put out for Newton's publication of Newton's Principia. They gave him copies of The History of Fish. So he had hundreds of these copies of this book stacked up in his home, and his wife was not too pleased with that. But Halley did more than that. He actually used the physics and mathematics that Newton had discovered, and he took a look at the orbits not only of the comet that he had seen in 1682, but what were believed to be previous comets in the years 1531 and 1607. And using Newton's physics and mathematics, he was able to determine that all three of those comets were actually the same comet on its orbit around the sun, returning every 76 years. And he made a prediction that the comet would return in the year 1758, which would be long after he was dead. He died in 1742. No one in science had made a prediction like that before. And this was going to be the acid test of Newton's laws. If Newton was correct and the comet returned, people would realize that the entire world had changed. And so, because Halley made this prediction, we now call the comet by the name that is known today. It's called Halley's Comet. Okay? Due again in 2061, if anybody's around then. Some of you may be. So what does a comet look like in a telescope? Well, in the telescopes similar to the ones we use, it looks like a small fuzzy dot. Okay? You need really huge telescopes in order to see a lot of detail in comet. It's not that difficult to see many of them, but they don't appear much more than a small cloudy dot in the telescope. Okay? We'll see similar things tonight. Okay? So those are the things that people were looking for when they were trying to search out comets. Okay? As the year 1758 approached, many astronomers throughout Europe began to search for Halley's Comet. And it became a point of national pride. The nation that had the astronomer that first recovered Halley's Comet would get a lot of good press. Okay? And their scientists would be regarded as the top scientists in Europe. Messier was one of those people who started looking early to see if he could find and recover Halley's Comet. Unfortunately, his search was delayed because he was using charts that were prepared by de Leslie, and de Leslie had made a mistake in his calculations. So for a number of weeks, Messier was looking in the wrong place. But finally, de Leslie realized his mistake and gave Messier the correct charts. And in Messier's own words, written much later in his life, the whole day, that day being January 21st, 1758, was very fine and without cloud, and in the evening I went over the sky with a telescope, keeping the limits of the two ovals drawn by de Leslie on the celestial chart, which was my guide. About 6 o'clock, I discovered a faint glow resembling that of the comet I had observed the previous year. It was the comet itself, appearing 52 days before perihelion. Okay? Unfortunately, Messier had been beaten, okay, because the comet had been first recovered by the German amateur astronomer Johann Georg Polish, who rediscovered it on Christmas Day 1757. Score 1 for amateur astronomers. So, despite getting beaten in the recovery of Halley's Comet, Messier redoubled his efforts and decided to find as many new comets as he could. He became very, very good at it. He discovered 21 comets, 14 of which he was the first one to see, and he actually won a medal from the King of France, King Louis XV, for his many comet discoveries. King Louis XV gave him the name the Ferret of Comets because he was so good at hunting comets out. Some of the comets that Messier had found. The Great Comet of 1769 was discovered by Messier in August of 1769, reached magnitude 0 and had a tail that was 60 degrees long in the night sky. Very impressive. Was observed throughout the world. It was noted much later, when it became important, that that comet was discovered in the year that Napoleon Bonaparte was born. And comets historically have been regarded as signs of and omens of bad luck and disaster. And many people regarded Napoleon as being that when he came upon the stage in Europe. Another comet that Messier discovered that wasn't actually named for him was Lexell's Comet. He discovered that in June of 1770. The reason why we call it Lexell's Comet, it was that the astronomer Anders Lexell computed its orbit, so it's named after him instead of Messier. It holds still the record as the closest comet to ever approach the Earth, 1.4 million miles, which is just a hop, skip, and a jump compared to most things in the solar system. And it became the first lost comet. After 2 return orbits, it was never seen again. And astronomers believe that so when he was searching for comets, okay, there were several problems that Messier had to deal with. And one of the most annoying from his point of view was the nebula. Okay? Occasionally, as he was searching the night skies for comets, he would come across small cloudy patches in the night sky that initially looked like comets, but weren't, because over time comets move through the night sky and eventually disappear as they move away from the sun. But these objects remained in the same place throughout the night and throughout the year as Messier was looking at them. But after seeing one, he had to spend some days and weeks determining that it wasn't a comet because it wasn't moving. And so he got irritated as he found these objects. Okay? And again, this is an example of scientists seeing something with telescopes they didn't really know what they were. Okay? So nebula in Latin means clouds. Okay? Just because scientists can give a name to something does not mean they know what it is. Think about dark matter and dark energy these days. Okay, that's a name for something that scientists still don't really understand that well. Back in the 18th century, it was nebula. Okay, so these little cloudy areas in the night sky, people didn't have a real good idea of what they were. But from Messier's point of view, they looked like comets, but they weren't. So they were impeding his search. In the year 1758, he discovered this object, okay, now known as the Crab Nebula. We'll talk more about this in a little bit. And at this point, he decided to do something about this. And in his own words, he said, "What caused me to undertake the catalog was the nebula I discovered above the southern horn of Taurus in September 12, 1758, while observing the comet of that year. This nebula had such a resemblance to a comet in its form and brightness that I endeavored to find others so that astronomers would not confuse these same nebula with comets just beginning to shine. I observed further with proper refractors for the search of comets, and this is the purpose I had in forming the catalog." Messier decided to write a catalog that would note these objects, their location in the night sky, and a visual description of them, so that future comet hunters would know that they were there and they wouldn't be fooled by them. Okay? He was using telescopes similar to this, small refractors, okay, similar to small telescopes that you would buy today as a gift for someone. So the telescopes that you would buy today as a hobby gift were probably equal in quality to the best professional telescopes that astronomers were using in the 18th century. And this is what Messier was using to find these objects. And because of that, these objects are very easily visible even in small telescopes. And we have telescopes that are much bigger here than the ones that Messier was using back in the 18th century. Okay. So he created this catalog, which is now known as the Messier catalog. Okay. He was aided in this by a younger colleague, Pierre Messier, and by the year 1774, both of them searching independently, they had discovered 45 of these objects, and they presented them to the French Academy for other astronomers to use. By 1784, together they had found a total of 103 objects, which were published in the French science journal Connaissance des Temps in that year. Modern versions of the Messier catalog contain 110 objects that were seen by either Messier or Messier. And this is a page from the actual first publication of Messier's catalog and the Connaissance des Temps. And the first object here, discovered on September 12, 1758, is the Crab Nebula, nebula from near the southern horn of Taurus. Okay? And proceeding on with 45 more objects after that. So Messier had some hard times later in his life. During the Reign of Terror, during the French Revolution, 1793 to 1794, the Academy, the French Academy, which was his employer, was dissolved, so he lost his job. Messier did too. Happily, they did not lose their heads. But even despite these troubles, Messier was still continuing with his comet searches. He discovered another comet on September 27, 1793, at the height of the Reign of Terror in France. Later, okay, things changed again. When Napoleon came to power, the Academy was reestablished. Both Messier and Messier were readmitted as members. Messier actually became the director of the Paris Observatory. And in 1806, Messier was awarded the Cross of the Legion of Honor from Napoleon himself for his many comet discoveries. In 1807, Messier's eyesight began to fail, and he ended visual observing for himself, and he died at the ripe old age of 86 in 1817. He is buried in the Père Lachaise Cemetery in Paris, which is the final resting place of many artistic and scientific notables from France. For Americans, it's probably best known as the final resting place of Jim Morrison. Okay? Messier's there with him. For many years, Messier's grave was lost. But in the 1980s, French and American amateur astronomers decided to do a search of records and a search of the cemetery, and they eventually located his tombstone in a kind of nondescript place. So now we know Messier's final resting place. So why is this important today, especially for us as amateur astronomers? Well, the odd thing is that today, very few people remember the comets that Messier discovered. What do they remember him for is this list of embarrassing, unfortunate objects that were non-comets that he included in his list. This is the Messier list. This includes the best and brightest deep sky objects that you can see with small telescopes, some of which, hopefully, if the weather holds, we'll be looking at tonight. Okay. So what are these objects? They fall generally into several classes. Okay. There are diffuse or gaseous nebula, open clusters, planetary nebula, which have nothing to do with planets, supernova remnants, globular clusters, asterisms, and galaxies. So let's talk a little bit about each of those as well as some examples we may be looking at. So in order to understand what these objects are, you need to know something a little bit about the life cycle of a star. So stars are all born the same way, but they don't end their lives the same way. They're all born in gaseous clouds. Okay? There are many of these clouds throughout our galaxy. And occasionally in these clouds, some area of the clouds become a little bit denser than others, and when that happens, they begin to contract and fall in on themselves. As they do that, their gravity increases and they begin to pull in more gas from other areas of the clouds. Eventually, these areas of condensation become so dense and hot that nuclear reactions start and stars are born. And what happens after that depends on how much gas was originally in the star. Okay? For stars like our sun, which are average size, they end their lives in a whimper. Okay? So stars like our sun can survive for several billion years, burning the hydrogen fuel in them to create energy. But eventually they'll use up their hydrogen fuel, and when they do, they'll expand into something called a red giant. And most of the remaining gas in the star will be blown off and into a cloud called a planetary nebula. So planetary nebula are the end phase of stars like our sun. This is how we're going to end up in several billion years. And after that, all that's left is a white dwarf, which is the cooling core of what was left of the sun. Okay? But stars that are more massive than our sun, by about 10 times, don't end in a whimper. They end in a bang. Okay? So they also use up their hydrogen fuel much quicker than the sun, usually over the course of only a few 100 million years, and grow into red supergiants and eventually explode in a titanic explosion called a supernova. Okay? And what's left after that is either a neutron star or a black hole, depending on how massive the original star was. So in Messier's list, we have some of these gaseous nebula in which stars are born. This is one that may be visible tonight. It's called the Swan Nebula, the 17th object on Messier's list, so it's M17. It was observed by Messier in June 1764. His description was a streak of light without stars, spindle-shaped, which is still a pretty good description. It's one of the brightest gaseous nebula visible in the northern sky, and it's about 5,000 to 6,000 light years distant. Okay. This is an image of the same nebula, and you can see why it's called the Swan Nebula. This is the swan's neck and the swan's body, so it kind of resembles a swan in profile. It's also known as the Omega Nebula. And the question arises when people see images like this versus what you actually see in the telescope is, why doesn't the view through a telescope look like the pictures that I see in books or magazines? And the answer is the human eye is very insensitive to color at low light levels. And telescopes are essentially light buckets used to try to pick up as much light as possible. But even with the large telescopes we have here, it's very difficult to pick up color in any of these objects. Okay? Some people may be doing electronically assisted astronomy here tonight with very sensitive cameras. Using those cameras, it is possible to see color and get images that look like this, but not visually. So don't be disappointed if you're expecting this. What you're going to see is this. But this is the way that Messier saw it 200 some odd years ago, and why he included it on his list, because it looked like a comet to him. So these are areas of star birth, as I said. This is a picture from the Hubble telescope, much better than any telescope that Messier ever had. And we can see here the areas of condensation. These are areas where these knobs are actually baby stars that are just about to be born. And when they're born, you can see the radiation from those newborn stars right here starting to shine and begins to blow away the rest of the cloud. So eventually star formation will stop. Another example, probably the best example that we can see here from the northern hemisphere, is actually not visible during the summer, but is visible during the wintertime. And that's the 42nd object on Messier's list, the Great Nebula in Orion. And inside the Orion Nebula is a multiple star system called the Trapezium. Okay? These are very young newborn stars. Stars that are being born out of these gas clouds, many of the ones that we can see are only about 10,000 years old. That sounds old to us, being human beings who only live about a century or so, but stars can live for billions of years. So a star that's only 10,000 years old isn't even out of the celestial maternity ward yet. So after these stars are born in these gas clouds, eventually the radiation from these young stars begins to dissipate the cloud, and what we're left with is stars but no gas. And that object is called an open cluster. One of the best open clusters that we can see in the summer sky was also discovered by Messier. It's the 11th object on his list, known as the Wild Duck Cluster, because a British astronomer in the 19th century, viewing it, thought it looked like a flight of wild ducks flying across the sky. Messier described it as a cluster of faint stars which may only be seen with good instruments, about 5,500 light years distance. And this is an image of that object. One of the better objects we can see in amateur-sized telescopes is an open cluster, in my opinion. Okay. So as I said, these star clusters, they're born in these clouds. Gas dissipates, and what you're left with is young stars. Eventually, over time, those stars begin to age, and when stars age, they change color. Bluer stars tend to be younger stars. Redder stars tend to be older stars. So you can determine the age of one of these open clusters by looking at the colors of the stars in it. Another object that we will be able to see tonight is the very famous Ring Nebula, M57. Observed by Messier in January 1799. He described it as a patch of light between the stars Lambda and Beta Lyrae, which has rounded borders, must be composed of very faint stars. They didn't realize back in the 18th century that some nebulae were made of gas. That wasn't determined until spectroscopy was invented in the 19th century. Messier thought that all of these objects must be composed of stars. It's just that his telescope wasn't big enough to resolve them. We now know that this is actually one of those planetary nebulas. Okay? This is an image. So this is what the fate of our sun is going to be in 5 billion years. There's the dead core of the star right there. The remains of the gas of the star is expanding out in a gas cloud that is illuminated by that core for right now. But these planetary nebula only last for a few tens of thousands of years before they dissipate as well. The name planetary nebula comes from this astronomer, who, if you want to learn more about, William Herschel. I'm going to give another talk in October and describe his life. He's my favorite astronomer in the whole history of astronomy. And if you want to know why, you can come in October to listen to that talk. But he gave planetary the nebula their name. Herschel is famous because he was the first person in human history to actually discover a planet that we know of. All the planets that have been known up to his time were discovered in antiquity, thousands of years ago. But in 1781, Herschel discovered the planet Uranus. And when he was searching the night skies, He found many of these planetary nebulae, and they looked very similar to the way Uranus had looked in his telescope, but dimmer. And again, this is a name, an example of astronomers giving a name to something that they don't really understand. He called it planetary nebula just because they look like dim versions of the planet Uranus, but they don't have anything to do with planets. But the name stuck, so we still call them planetary nebula. This is the famous M1, first object on Messier's list, the object that got him to start the catalog. Discovered in September 1758. It's about 6,500 light years distant. Possibly one of the only deep sky objects that we know the origin of, because, and a better picture of it, in the year 1054, Chinese astronomers noticed a supernova appear in the constellation of Taurus. They called it the name guest star, a star that appeared out of nowhere. And that star was actually bright enough that it was brighter than the planet Venus and was visible in the daytime sky for 23 days after its discovery. Okay. There are no contemporaneous records from Europe at that time that note this discovery. However, paleontologists, not paleontologists, but archaeologists believe there are records from the pre-Columbian America. So this is a drawing of what the Crab Nebula supernova would have looked like on its first morning of existence, July 5th, 1054, very near to the crescent moon. In areas of the southwestern United States, there are many pictographs from Native American peoples who were around at that time, and many of these that archaeologists have found, they believe, are representations of the Crab Nebula supernova from the year 1054. So another type of object, another type of star cluster, are globular clusters. One of the ones we may be looking at tonight is in the constellation of Pegasus. It's M15, discovered by Messier in June 1764. He described it as nebula without star, which is a very good description of the quality of Messier's telescopes at that time. Near the head of Pegasus and Equuleus, it is circular and its center is bright. It's about 30,600 light years away. Nebula without star. That's what it looks like in modern amateur telescopes. These globular clusters are clusters of between 500,000 and 1 million very ancient stars, some of the most ancient stars that we have in our universe. There are about 150 or so of these clusters orbiting the center of our Milky Way. Most galaxies have a similar number orbiting around them. And we still don't have a really good idea as to how they form. Scientists and astronomers are still trying to figure that out. Messier wasn't perfect in his search for comets, and occasionally he made a mistake in his catalog. And those mistakes are kind of interesting to find, just for the sake of saying that you can take a look at an object that Messier mistook. And so in the constellation of Aquarius is the 73rd object on Messier's list, which he described as a cluster of 3 or 4 faint stars, which at first glance resembles a nebula and which does contain some nebulosity. Modern images don't show any nebulosity at all, and astronomers believe this is just a chance alignment of stars. They're not actually a true cluster. This is an image of M73. And lastly, M31, the great nebula in Andromeda. One of the few nebulous objects noted in pre-telescope days. It was actually first noted by the Persian astronomer Al-Sufi in the 10th century, was observed by Messier in August of 1764, and the astronomer Simon Marius, who is a pre-contemporary of Messier's, described it in 1609 as like the light of a candle shining through horn, which is still a pretty good description of the way that it looks in modern telescopes. But this is an image of the galaxy M31, the great Andromeda galaxy. So unlike all the objects that we've talked about so far, which are all objects that are in our galaxy, this is a completely separate galaxy. It's about 2.5 million light years away. That's a modern estimate. And here in this image, you can see there are 2 other Messier objects that are visible with it as well. This is M33, the Andromeda Galaxy. There's a small elliptical galaxy just to its south, M32, and a dimmer elliptical galaxy, 110, the last object in Messier catalog, just above it. In the 1920s, Edwin Hubble became interested in looking at these objects with the largest telescope in the world, which at that time was the 100-inch Hooker telescope out in California on just above Los Angeles. And at that time, people believed that these objects were star-forming regions in our galaxy, but through analysis of the brightness of individual stars, which that telescope was the first telescope to actually resolve individual stars in the Andromeda Galaxy, Hubble was able to determine that it was a completely separate galaxy. And so this is the first time that people realized that our galaxy was just one of billions of galaxies in the universe as a whole. So what is Messier's legacy all these 250 years later? Well, people are still looking for comets. Most of comets these days are actually not discovered by individuals. They're discovered by robotic searches, which has become much more efficient at discovering them. But it seems like we haven't had a great comet for a long time now. We did have a couple of pretty good ones back in the late 1990s. So this is Comet Yakutaki, which appeared in skies over New Jersey about 1997, I think, if I remember right, and Comet Hale-Bopp, which appeared about a year later. They were actually the first comets that I've seen that were visible to the unaided eye without any optical aid at all. And they caused a big interest in amateur astronomy back at that time. But the comets that Messier observed in the 18th century were actually even brighter than these. And in terms of comets that are brighter than these, we're still waiting for one to come around. We have the Messier catalog, which, if you're interested in pursuing astronomy as a hobby, after you get tired of looking at the moon and the planets, this is where you go. So start working your way through the Messier catalog and see what you can see. Even small telescopes will probably be able to view all of these 110 objects to some degree or another. If you feel really super inclined, you can undergo the torture of a Messier marathon. So it just happens because of where the objects are located in the night sky, that during the new moon phase closest to the spring equinox, so late March, early April, it's just barely possible to see all 110 Messier objects in a single night. So people that want to try that challenge come out, and we've had several of them up here at Jenny Jump. And starting at sunset, you start searching for Messier objects in the west, and you search all night long through to dawn to find how many Messier objects. Finding 110 is a real challenge. I've done it several times up here, and I think my best record is 104. But the other 6 were really tough. If you're interested in looking at reading about Messier's objects, here's some references. A little bit dated now, but still probably the best reference for amateur astronomers is Burnham's Celestial Handbook, 3 volumes, written back in the 1970s by a man who is deserves much more credit in the astronomy community than he ever gets, Robert Burnham Jr., who in my opinion was a genius, an unheralded genius. Stephen James O'Meara, the Messier objects, a very good description as well as drawings of these objects, what they look like in small telescopes. And if you're interested in pursuing a Messier Marathon Field Guide. All of these are available on Amazon. That's my talk tonight. I hope you found it enjoyable. Just some notes here from UACNJ. And if anybody has any questions, I'll be happy to try to answer them for you.
All right, everyone. First of all, big round of applause for Bill. Thank you very much.
You're welcome.
And we'll get into questions in a moment. I just want to remind everyone of the format, because since we are broadcasting Also, live, I need to come to you with the microphone if you have a question out there, so raise your hand. But we'll start off here with a online question.
Right.
And the first one is, and I didn't catch this particular reference, maybe you're aware of it. Do we know why the comet had 6 tails? And maybe you can generalize that a little bit to why do comets have multiple tails?
Okay. So comets have tails because they're made up of gas and ices. Farther out in the solar system, they remain solid. But as they approach the sun, those gases and ices begin to melt. And when that happens, a tail forms from the comet. Okay? If the comet nucleus is relatively solid, you'll only get one tail. Or sometimes you'll get a gas tail and an ion tail, which you could see in that image of Comet Hale-Bopp. But comets like the Great Comet of 1744 with multiple tails, they're usually in the process of the nucleus starting to break up. And so you have multiple tails coming out from comets. And that's what the cause of multiple tailed comets are.
They even have different directions, if I remember correctly, related to how easily they're moved by various forces.
Mm-hmm.
Got you. Do we have a question out in the audience? Okay, 1 second.
Out of curiosity, since if old telescopes looked like our current telescopes, what did old amateur telescopes look like? I'd have to imagine they were even smaller, right?
Not necessarily smaller.
Thank you.
But if you take a look at telescopes from the 1950s, which is really when commercial telescopes started to become available, you'll see that virtually all of them were like small Newtonians, 6 inches or less in diameter. Nowadays, we have a much greater variety. Okay, before that, before the 1950s, a telescope was really a rich man's toy. The average person couldn't afford one, and there was an amateur astronomer named Russell Porter who lived in the 1920s, and he started the movement for amateur telescope making, which allowed normal people, regular people, to actually make their own telescopes. And so that became a separate hobby from amateur astronomy. People would actually make their telescopes and then use them.
Good question. Thank you. Another online question. Is there any particular reason historical comets were often described as visible during the day, but more recent comets seem barely visible even at night? Is it just modern light pollution?
Light pollution probably has a lot to do with it, but I think it's basically random chance. I think if we got one of those great comets that were visible back in the 18th and 19th centuries to come around today, it would also be visible in the nighttime, in the daytime sky as well.
There was a continuation to that, or does it maybe have better something to do with our current modern instrumentation?
So we're definitely much better at finding comets than we were in the past. Back in the past, comet hunting was an object, an activity for individuals. And we found a lot of really bright comets and bright comets, but a lot of dim comets we weren't aware of until they were either gone or just upon us now. We've realized that comets in our solar system can be kind of dangerous. Astronomers believe that it was a comet that hit the Earth 65 million years ago that caused the extinction of the dinosaurs. And one of the major activities of observatories today is they're trying to locate all of those comets and asteroids so that they know where they are. If we know where they are, that's half the battle, because we'll know if there's actually a good chance that they could hit the Earth, and if there is, we may be able to do something about it.
Comets' relative velocity are like an order of magnitude than typical asteroids, something in that nature?
Yeah.
Is there an estimate? Here's another online question, then I'll go back to our live audience. Is there an estimate of when all the stars in one of the star nurseries that you had mentioned earlier, star nursery nebulas, will be formed, and when the nebula no longer has available gas, no longer nebulous?
I don't have a good estimate for that off the top of my head. I would say a few 100,000 to a few million years max, but that's just a guess on my part. But the process of star formation is ongoing, because when supernovas explode, they create these clouds of dust and gas in our galaxy. And so actually, we here on the Earth and our sun, we actually have heavy elements, and those heavy elements were created in the supernovas of long ago.
Thank you. Do we have another question out in our live audience? Yes, ma'am.
How big is the Milky Way?
So the Milky Way is really big. It's about between 150 and 200,000 light years in diameter. It's a big flat disk, kind of like a plate. At its center, it's only about 10 to 20,000 light years wide. Okay, but you have to think about what that means. So 120,000 light years. So if I shone a flashlight on one side of the Milky Way, it would take 120,000 years to get to the other side of the Milky Way. And light travels at 186,000 miles a second. So the Milky Way is pretty big.
Good. Another online question. What's everyone's favorite space object to observe? And maybe this was a question, but well, let's start with Bill here. And maybe other people can chime in. But Bill, what is your favorite object to observe?
My favorite object is the Orion Nebula in winter. Has a lot of detail in it. But probably my second favorite object is the Ring Nebula, and we're going to take a look at that tonight.
It's very prominent in the sky, and it's a very cool-looking object, for sure. And I like galaxies myself. If anyone else wants to chime in, please do. But I will also take any other questions. Any questions from the live audience? One over here.
Space is funny. But so I am curious, like, what precisely is in the rings that surround a few of the planets, and also, like, is it just general space debris that falls into orbit of it, or is it like pieces of the planet itself, or is it just like a big old mishmash of all of that?
So you're talking about like the rings around Saturn? Okay. So what happened there was when planets form out of the gas and dust that our star formed out of, around the planets, many planets large like Saturn have moons start to form. And in Saturn's case, there was a moon that tried to form that was too close to the planet itself. And if you've ever tried to form like a snowball in the wintertime that's very loosely packed, if you jumble it around a little, it just kind of falls apart. That's what happened to that moon around Saturn. And so as it was forming, it fell apart, and all of the material that would have gone into that moon got spread out into the ring that now exists around Saturn.
And it has something to do with how the moons orbit the planet too, isn't it?
Yes. She has a follow-up question, I think.
Sorry?
This is like a continuation sort of the question, but how long did that process take? And also, like, is this a common thing that'll happen with like planets or things that start to surround planets?
The answer to that second part of your question is yes. So in the planets of our solar system, we didn't know this until the 1970s, but Jupiter has a ring, and Uranus has a ring, and Neptune has a ring. None of those rings are as bright and prominent as Saturn's rings, but they do exist. So this process is actually pretty common. Okay? I don't know off the top of my head how long it takes. I would imagine on the order of millions of years, but that's just a guess on my part.
Good question. I think that's it for. Oh, there was a comment. Maybe something you could add even to your presentation. Someone said that you could say that Messier was crabby about finding an object that wasn't a comet.
He certainly was, but it was a very productive crabbiness.
Any other questions from our audience here? One more.
Also, you specified that planetary nebulas and stellar nebulas are a different thing. Do you have any ideas where planetary nebulas come from? 'Cause
So-
I'm presuming their origin is different, right? Otherwise, we just call them both stellar nebulas.
So planetary nebulas are actually the end phase of life like our sun. So when our sun gets old, it's going to become unstable, and it will become a red giant star. And as those stars like our sun become unstable and begin to use up all of their fuel other than hydrogen, they start to pulsate. And as they pulsate, they begin to take most of their gas and throw it off into essentially a bubble that surrounds the star. So what you're seeing when you're looking at an object like the Ring Nebula, you're seeing that bubble, but you're looking at it, and as you're looking at it, the gases that you're looking through are not very dense, but the gases around the edge are denser, so you get to see them brighter. So it looks like a ring. Okay, the nebulas that stars are born from actually exist. They have existed from the formation of our galaxy. Back then, they were composed mostly of hydrogen, but over the billions of years that our galaxy existed, they've been seeded by supernovas with other elements, and that's what stars are being created from today.
Okay, unless we have a burning question out in the live audience, again, no questions it seems. I think we're going to end that there for tonight. We do have observatories open, and as Bill had mentioned about EAA and seeing color in some objects and things like that, we should have that available at one of the observatories back there also, at least one. So please do stop by. And of course, the moon's very prominent now, so I'm sure we'll be also taking a look at that. I want to remind everyone about light safety, please. You do want to avoid walking around shining lights into people's faces as we're going from observatory to observatory, but safety does rule the day. Please use your headlights as you're leaving, and if you feel you do need to use a flashlight, please don't hesitate to do that. I think that's it for our program tonight.
Just one more thing for me.
One more night.
So you're free to visit any of our observatories, and they have many different types of telescopes. But as it gets a little bit darker, right now it's still pretty light. I'm going to be down in the Greenwood Observatory, which is the observatory down back of the house, with our 16-inch telescope, and hopefully we'll be able to see some Messier objects. So if you're interested, stop down there when it gets a little bit darker.
Yeah, the Greenwood's a little lonely down the slope a little bit, so do stop by. That's a pretty cool Newtonian telescope to take a look at. So thank you, everyone.
Thank you.